In today's video, I will show you how 3D printing can be used to make practical prints for cinematographers. Most of you know me from these videos as the person who gives advice on how to do something with a 3D printer. But nowhere are videos showing what I'm using the 3D printer for. In today's video, I'm going to try to fix that. Since one of my hobbies is also making videos, today I'm going to try to show what 3D printing can be used for in this industry. When I started with videos, I used to shoot videos on whatever I could get my hands on. But one day I made a decision that I wanted to do these videos differently, better. So I decided to invest in my hobby and got myself a Panasonic GH5. If some of you know or even have this camera, you will surely agree with me that there is basically no need to buy anything to go with it. Well, except for a few things. If you decide to shoot in direct sunlight, you will definitely find this sunscreen protector or this lens hood for the kit lens useful. If you use more than one battery in your shooting, this case will definitely come in handy to distinguish between the discharge and the charged battery. The same can be said if you use multiple lenses and start to lose their caps. After a few videos, I decided that I wanted to shoot on multiple cameras at the same time. That's why I focused on the Blackmagic design brand and got a Blackmagic Pocket Cinema Camera 4K and a Blackmagic Pocket Cinema Camera. The huge advantage was that I could use the lenses I already had for the Panasonic GH5. With the new equipment, I started to solve new problems. For example, the possibilities of expanding these cameras with attachable accessories. There are so-called cages for this, but they are not exactly cheap. So I started looking at alternative options using 3D printing. Finding a complete cage, including manual focus or a lightweight version that only fulfills the most important features, was not a problem. These cameras don't have autofocus, so I started looking for a manual focus option. It's not a problem to find a full manual focus or different focus rings specifically for your type of lens. There is even an option to find a full rig for placing the camera on your shoulder. On the Thingiverse server, you can find a model of the focus ring that can be opened in OpenSCAD and adjusted to your lens using a few parameters. It took only a moment and I was already printing focus rings for all my lenses I had at the time. I used a Trilab Deltic 2 3D printer with the FlexPrint extension, which we will talk more about in an upcoming video. The material I used was FlexFill TPU 98A Sky Blue from Filamentum. This material was absolutely seamless to print and the final focus ring was easy to slide onto a compatible lens. I originally tried printing these focus rings from PLA material. This material is not elastic. A slight imperfection or a bit different dimensions was enough, and either the ring would not slide on or I had to deal with compensating for that imperfection. Enough about the focus rings. Let's take a look at other useful things like these memory card and USB flash drive holders. You can even find different boxes in which you can transport your memory cards on the go. If you take a little time to search, you can find some really nice boxes that will exactly meet your expectations. Presentation of the prints in the form of a photo or video will for sure catch the eye on social media. To help you to do this, you can print out, for example, a rotating platform like this. It can be found in the form of manual control as well as electronic control. If you are more interested in still images, then you might like this little photo studio. Anyone who has ever come into contact with a tripod knows about quick release plates. Unfortunately, many manufacturers use their own shapes of quick release plates. One of these shapes or types is the Arca Swiss, which is becoming more and more used lately. On the Thingiverse server, it is possible to find this plate to print, including the counterpart that you attach to the tripod. You can even find a model for attaching the Arca Swiss quick release plate to your belt. Personally, I have been in many situations where I have found it easier to draw the quick release plates myself then wait for it to come from the store within 2 or 3 days. It even gave me considerable freedom in their shape, printability, and final usability according to my needs. In the end, however, I still ended up with Arca Swiss, where I designed several custom plates or adapters to suit my needs. In order to continue using my main tripod, along with the Arca Swiss quick release plates, I created an adapter like this. For lighter stuff, I made a model of my own vise for these Arca Swiss quick release plates. Here, for example, is an adapter to allow you to attach a Blue Yeti microphone to any vise for the Arca Swiss. So it's no problem to attach this microphone to a tripod, for example. Next, I created this larger Arca Swiss type plate which I attach to my workbench. This way I can attach, for example, a camera or a microphone to my workbench. Basically, I can attach anything that I am able to attach to this Arca Swiss quick release plate. I would say we have talked about Arca Swiss quick release plates quite a bit. Let's take a look at something with a touch of electronics. With the old Blackmagic Pocket Cinema camera, I was troubleshooting an issue with syncing video footage with the Blackmagic Pocket Cinema 4K and Panasonic GH5 cameras. The only camera that was able to keep track of the shared timecode information was the Blackmagic Pocket Cinema 4K. With both of the older cameras, I had to solve this by recording the audio signal into one of the channels of the audio track currently being recorded. With the old Blackmagic Pocket Cinema camera, I solved this problem with a little adapter I designed. It divided the audio signal into left and right. Basically, a microphone was plugged into the left channel and a timecode source was plugged into the right channel. The timecode source was plugged in using a regular 3.5mm jack that you might know from regular headphones for your computer. Unfortunately, this adapter did not stay in position. So I printed out a holder like this, which I just screwed onto the camera and attached the adapter to it with zip ties. Blackmagic Pocket Cinema cameras are generally known for their poor battery life. They last between 30 and 40 minutes of recording. Many users of these cameras solve the battery life problem by using an external power supply or by replacing the battery with a so-called dummy battery. This allows an external power supply to be connected as a replacement for the battery inside the camera. The advantage is that you don't have to think about the condition of the battery inside the camera. The disadvantage is that you always have to power the camera with an external power supply. Since this camera can connect to an external power supply, the manufacturer did not add the possibility to lead the dummy battery cable out of the camera body. Instead of mechanically damaging the battery cover or removing it completely, I decided to draw a new cover. All I had to do was to make a few prototypes and a working sample was born. After that, all I had to do was rearrange the cables a bit and the camera was ready for use. As one of the last problems I solved was again the timecode synchronization. Currently, I have only two cameras, Blackmagic Pocket Cinema 4K and Canon C70. Both of these cameras can accept timecode and save it to the final video file without affecting the audio track. The Canon C70 can even broadcast the timecode stored in it via the BNC connector on the front of the camera. Unfortunately, the Blackmagic Pocket Cinema 4K can only accept the signal via the audio input. Therefore, I needed to create a reduction from the BNC connector to the 3.5mm headphone jack. This reduction does exist, but its price is slightly too high. At the same time, this reduction will be used to set the timecode in the Canon C70 using the audio signal from my phone and a dedicated application. The making of this reduction started like most DIY projects. Basically, I just purchased cables with these connectors and expected to cut them and connect them with a soldering iron. However, I didn't like the result, so I tried to repeat the process. But the second attempt was not much better. So I decided to try to make the wall connector myself. I disassembled the original connector and soldered the wires leading from the BNC connector directly to the jack 3.5mm connector. At home, I found an old 3D pen from 3D Simo and decided to try to reconstruct the wall connector using the 3D pen and PLA material. But you can't create a final, perfectly smooth shape with a 3D pen. That's why I used a soldering iron set to a temperature of around 240 degrees to smooth the creation. The result still didn't look as nice as I wanted, so I took a heat shrink tubbing to the rescue. Since both cables had two connectors, I decided to use the older parts of these cables as well and create a second backup reduction. It didn't turn out as I expected, but it is a backup cable, so the appearance doesn't matter. In addition to the things I have shown you, you can find lots of other and better ideas and tools to print. For inspiration, I recommend for example the YouTube channel of Alexander Chappell. Here you will find, for example, a video tutorial for a simple camera arm or drawers to organize your equipment or other things. I hope you enjoyed the video and found it useful. If so, hit the like button and subscribe to the channel. If not, write your thoughts in the comments below the video so I can learn from them. If you really want to hit the dislike button, please do it twice. If you would like to support this YouTube channel, check the links below the video. Thanks for watching, see you next time, and remember, even the impossible is possible.